Hello everyone, welcome to the video series of NAT in Palo Alto Firewall. In last video, we discussed topology, which we will be using in this entire video series. And then we implemented two tasks as well related to the NAT assignment. So there we discussed how to implement NAT policy in case of dynamic IP and port. So we did a NAT with the interface IP address and we also tried to do a NAT with the virtual IP address. So in this video, my focus will be on the destination NAT with some port forwarding concepts, plus when to do a source NAT and destination NAT in a single flow. So we will implement task 3 and 4 in this video. So task 3 says router R2 has to be published over the internet via public IP address, which is 203.115.100.105. And for testing, we will be initiating a traffic from internet to this public IP address on port 10,000, and that will further be natted with router IP address, and the port will also be translated from 10,000 to 22. So it has both destination NAT as well as port forwarding. So let's go to the firewall and try to implement this. And now you have to remember the NAT flow while implementing this lab. Go to Palo Alto Firewall, go to policies and then NAT. So click on add and name the policy as port forwarding. Go to original packet. Traffic is coming from internet now, and the destination zone will also be internet in this case. You can refer your notes why it is from internet to internet. So source zone internet, destination zone internet, and traffic will be coming from internet. So source ideally should be any, but I don't want to keep this setting as any. So let me first verify my IP address and we will allow only that IP address. So I'm executing what is my IP.com and my public IP address is this. So we will allow just this IP address. So /32. Destination address would be public IP address 203.115.100 and 105. Go to translated packet. This time we will enable destination, and the destination translated address would be 136.126.120 and translated port would be 22. So go back to original. In this case, service would be 10,000. So let's name the service as TCP_10,000 and the port number is 10,000. So click on OK. So original from internet to internet, source IP address as my public IP address, destination is firewall public IP address, port is 10,000, and the destination will be translated with router R2 IP address on port 22. Click on OK. Go to security, click on add and name the policy again, for example, as port forwarding. Now traffic will be coming from internet. Source address would be my public IP address. Destination now would be a second routing lookup will be done. So destination is in DMZ. So destination zone as DMZ, but the destination IP address will remain 203.115.100.105, which is the public IP address. Application, I'll keep that as any service, any action allow, logging not required because we will not be able to see, and click on commit. So let's wait for policy to be pushed. Click on new session here, SSH, modify the port number and then IP address 203.115.100 and 105. If all is good, the routing is okay for this public IP address, we should be able to see a login prompt from router 136.1.126.120. So let's see if policy has been pushed. Wait, and yes, policy has been pushed. Let me click on open. We don't see authentication prompt, so we can verify that in logs if we actually see have a traffic or not. Go to source session all filter and do a filter on destination IP address, which is 203.115.100.105. It has been discarded. So it says, okay, why it has been discarded, let me tell you. So go to security, port forwarding, and instead of application default, it keep that as any, because Palo Alto assumes SSH is on port number 22 because the signature has been created in such a way. So we have modified SSH to be used on port number 10,000. So that is the reason it is getting dropped. So now I have selected the policy, the service information as any, or you can select 10,000 port here. So we did create 10,000 port. So click on select, add, and let's select this 10,000. Okay. Click a commit again. So discard in a session table entry, that means traffic is getting dropped. So internet to DMZ, it is being dropped on port 10,000 because Palo Alto does identify that application as SSH, and for Palo Alto the port number is for this application is 22. So that was the reason it was being dropped. So let's see if policy has been applied, and we should see now authentication prompt. So restart session, we have authentication prompt, log into the router and verify the IP address. So 136.1.126.120. So natting did work, port translation was being done from 10,000 to 22. Go back to firewall, verify the session table entry. Now this time this session is active from my public IP address to firewall public IP address. Source remains same this time, and now the destination IP address is modified, and if you see destination port was 10,000 and now it is 22. So it is good now. Let's move to lab number 4. Lab number 4 is interesting. Now it says delete routing from R1 and R2 and configure NAT so that R1 loopback should be able to access R2 loopback. So what to do here? If you see, the task says remove the routing from R1, remove the routing from R2, and then access R2 loopback from R1 loopback. So let me do that, and then we will see what changes we need to do on a firewall. So this is R1, go to configuration mode, delete protocol static route, and then commit. Go to R2, configure delete protocol static route 0, and then commit. So we don't have routing on both R1 and R2. So logically, so if I'm trying to do a ping from interface 130.1.1.1, we should see a network unreachable message because there is no route on the router. Now how to reach, how to enable this connectivity? Go to the topology again. So this router can only communicate with 136.1.125 network, and this router can only communicate with 136.1.126 network because of the connected routes. So we need to do a change. We need to initiate a traffic in range 136.1.125 so that can reach the firewall because of the proxy ARP configuration. And then when traffic leaving out from the firewall, we should do a NAT with 136.1.126 subnet IP address, for which R2 can always respond, and that traffic can reach to firewall because of the proxy ARP. So we cannot initiate traffic on subnet apart from 136.1.125. Similarly, R2 cannot initiate any traffic for subnet which is different than 136.1.126. So let's pick up one virtual IP address from here, do a destination at. In the same flow, let's use the interface IP address, don't require a virtual IP address. Let's pick up this interface address as a source NAT when traffic moving out from the Palo Alto firewall. So let's replicate this and then we can test the results. So go to firewall, then go to NAT, click on add, name R1-R2 and then no route, original packet LAN, then destination zone will also be a LAN because we will be initiating traffic on 136.1.125 network. Click on add 136.1.125. This time it will be 130.1.1.1. So let's use single IP address 130.111/32. Destination IP address would be 136.1.125. Let me see if we have a virtual IP address. So what you can do is I'll update this topology, this assignment with the exact virtual IP address details so that there should not be any conflict while you guys are doing this lab. So 136.1.125 dot let's use as 239. I know that is a free IP address, so we'll use that 136.1.125.239. Go to translated address, enable this translation, and this time IP address would be 141.1.1. So firewall will translate the destination IP address. So no change in translated port because whatever destination port will come, same will be forwarded to the R2. No change. We need to do source NAT as well because R2 can only talk to 136.1.126 subnet. So go to translation type, dynamic IP input, interface address. So I need to see which interface is configured with 126 subnet. Yeah, that's the right 1/4, and click on OK. Awesome. So from LAN to LAN, 130.1.1.1, which is, and what basically we can do is we can have a separate NAT rule as well. So for the source NAT. So from LAN to LAN 130.1.1.1. So let's keep this as an it should work. So click on, go to security policies, and then let's see if we can use same policy. Maybe not. Let's create a new one. R1-R2 and then again no route. Go to source zone as LAN. Then source IP address would be 130.1.1.1 or 0/24. Go to destination zone, this time would be DMZ because lookup will be done on 140 IP address. Destination IP address is 136.1.125 dot 239 we did use, so that is the IP address. Then application, keep it any, service any, because we are not changing anything here, and click on actions. Action say allow, logging disabled, click on OK. So we have a security policy from LAN to DMZ 132.136.1.125.239, application any, and then action any. So policy is there. Let me commit the changes. 1 second, let me verify that again for the security policy and NAT policy if all is good. So source LAN subnet is good, then destination DMZ 136.1.125, let's 32 for example. Then it does work without /32 as well. So click on application, so all good in security policy. So do a commit, and once that commit has been done, we'll test the changes by doing a, a ping on 136.125.239 IP address, and then we will verify the session table entry if that works. So click on close, go to router R1, ping 136.1 and IP address was 125.239, interface 130.1.1.1. We can see response back and then verify on the firewall. Show session all. So that's the log entry 130.111. We are initiating traffic on 136.1.125.239. Source is being translated with the interface IP address, and the destination has been translated to 140.1.1.1. So that's how you can implement source NAT and destination NAT in a single flow in Palo Alto firewall. So that's all for this video. Try to replicate these 4 labs, and in next video we will do U-turn 3-leg and U-turn 2-leg task. So thank you very much for watching this video. Hope you are enjoying this video series from Troika system. Thank you.